Good day everyone, good day fellow cadets. I am Jesse Carias Jr. and I am going to show you how to do radar plotting. So first, we have our own shape data. Our speed is 10 knots and our course is 120 degrees true. And our target's data. So at time of 0830, we have a bearing of 040 degrees true and a range of 6 nautical miles. So at 0836, the bearing of the target is 050 degrees true and 4 nautical miles. So first, we need to identify what scale to use. So we will use 1:2 scale, or this one with 12. 1:2. So it means that every ring is equivalent to 2 nautical miles. So 2, 4, 6, 8, 10, and 12. So first, we need to identify our own ship distance or E to R. So to solve this, we need a formula. Distance is equal to speed times time. So our speed is 10 knots and time is the time interval. So 0830 to 0836, so there is a 6 minutes interval. So the time is 6 minutes. So this is 10 nautical miles per hour. So first, we need to convert 6 minutes to hours. So to do this, 6 minutes divided by 60, we have 0.1 hours. So we will put it here, 0.1 hours. So we will crush this out, and then 10 times 0.1, we have 1.0 nautical miles. So this is our distance, or E to R. So next is we will plot the target's observation. So at 030, the bearing of the target is 040 degrees true. 040 degrees true. And a range of 6 nautical miles. So 246 here. And then the second observation at 036, the target is 4 nautical miles and bearing of 050 degrees. So 4 nautical miles to 4 here. So in our first observation, we will label it to R. And we will put the time 0830. So for the second observation, we will label it M. And the time 0836 hours. Next is we will draw a line to the center, near to the center. So this one is our relative motion line, which is the RML. So next is we need to find the CPA distance and the CPA bearing. So in order to get the CPA distance, we will measure 90 degrees to the center. So that is 90 degrees. We will use a compass divider to measure the CPA distance. All right, and we will put it to the scale. So this is approximately 2 nautical miles. So our CPA is equal to 2 nautical miles. And then next, we need to find the CPA bearing. So to get the CPA bearing, we will measure it from our ship to the target. Okay, from our ship, which is from the center to the target. So from here to put a line here. So that is 110, 111, 112, 113. So the CPA bearing is 113 or 113 degrees true. We have our CPA distance and we now have our CPA bearing. Next is we need to find the target's true course and true speed. So since we already have our ship distance, we will put it next to our R. So we have a course of 120, 120 here. We will drag this to R, next to R, 120. Alright, that's it. We will put a line. And then our E to R is 1 nautical miles. So we'll measure again in our scale 1 nautical mile. E to R 1 nautical mile. So this is our E. And then we will put a line, draw a line from E to M. So to get the target's true course, we will just drag this E to M line to the center. And we have 175, 76, 77, 78. So the true course of the target is 178 degrees true. Next is we need to find the true speed. So get the true speed, we need, or we will use the formula speed is equal to distance divided by time. So we will measure the distance between E to M. So the distance from E to M is approximately 2.5 nautical miles. 2.5 nautical miles divided by the time interval, which is 6 minutes, and then we converted it to hours, 0.1 hours. So we will divide it. We'll have 25 nautical miles per hour or 25 knots. So this is the target true speed. So we now have our true course and we have our true speed. So the importance of labeling R to M, R, M, and the targets is that in radar in radar plotting, it enhances the navigator's ability to interpret the radar information accurately, so that track objects and maintain situational awareness. So these labels aid in identifying range, tracking specific targets of interest, and distinguishing between multiple targets on the radar display, thereby facilitating radar operation and decision making. So that's all, and thank you.